Good morning, everyone. Yesterday we started with the chapter Lines and Angles, and we revised the definitions which you already have done in previous classes, and it was like a revision class of what you have done in lower classes. But after the class, after watching the video, a Google form was shared in which I found many of you not scored well. So there may be two reasons for it. Either you did not understand the concept previously as well as in the revision class, and secondly, that you do not take the Google form seriously and you just fill it for the sake of attendance. So if you are filling it just only for attendance, then you must rethink that your teachers are analyzing your grades also on the regular basis, so that also may be counted for your assessment. So do take the Google Forms seriously and watch the videos carefully before you fill the Google form. And if you have any query, please go ahead and ask, but do not have any doubt while filling the Google form. So today we are going to revise the definitions of the chapter again so that your concepts are clear. So the first definition that comes in lines and angles is angles, which you already know when two rays meet at a point. So the point is called a vertex. So here ray 1 and ray 2 are meeting at a point, so they are called the lines are called rays here, and the point is called a vertex. Now when there are more than one angle, so they must have a relation in between two. So we are now talking about related angles when there are more than one angle, that is two or more angles are there. So the first kind of related angles are complementary angles. So what are complementary angles? Complementary angles are those whose sum is 90 degree. Now look at the first figure. Here the two angles are 25 degree and 65 degree. If you find their sum, it is 90 degree. So they are called complementary angles. Look at the second figure. Here also the angles are 50 and 40. So their sum is 90. Hence they are complementary angles. Now what is the difference between the two examples given here? Can you identify the difference? In first case, they are complementary as well as adjacent because there is a common arm in between the two angles. But in second case, they are not adjacent but they are complementary. So in both the cases they are complementary, but in first case, in case of 25 degree and 65 degree, they are adjacent also. So remember that complementary angles need not be adjacent. They can be adjacent, but it is not compulsory that they should be adjacent. That is why in both the cases they are complementary angles. Now look at the second definition, that is supplementary angles. If two angles have their sum equal to 180 degree, then they are called supplementary angles. Now look at the first figure. There are two different angles, 110 and 70, and their sum is 180. Hence they are supplementary angles. Now in second case, they are again adjacent, but their sum is 180, so they are supplementary angles, plus they are adjacent also. So they will be given a special name. We will discuss it later after some time. Now let us talk about adjacent angles. Adjacent angles are those which have a common arm and a common vertex. Like in figure 1, angle ADB and angle BDC are adjacent because they have a common arm BD and they have a common vertex D. Now look at figure 2. In figure 2 there are two figures given here. So 1 and 2, angle 1 and 2 are forming adjacent angles, and in second figure, angle AOB and angle BOC, they are forming linear pair. BOC and COD are forming linear pair. So are these all forming linear pair? The answer is no. Where they do not have a common arm but a common vertex, then they are not adjacent. They should have common arm as well as a common vertex. For example, AOB and COD have a common vertex O, but they do not have any common arm in between them. So angle AOB and angle COD are not adjacent. Now look at linear pair. I said I'll be discussing it later. So here the two angles, their sum is 180 degree. So they are supplementary angles, as well as they are forming adjacent angles also. So whenever two adjacent angles are supplementary, then they are called linear pair. Or you can say two adjacent angles, if their sum is 180 degree, they are forming linear pair. Or in another words, you can also say if two angles lie on a straight line, then they are forming a linear pair. Look at the second figure. There are some examples given here. So 1 and 2 are forming linear pair. Then 3, 4 forming linear pair. 5, 6 are forming linear pair because in each case the sum is 180 degree. Now vertically opposite angles are easy to identify whenever two lines intersect at a point. So in this example, the lines are meeting at 2 points circled by red color. So angle 1 equal to angle 3. The vertically opposite angles are equal to each other, and angle 2 equal to angle 4, angle 5 equal to 7, and angle 6 equal to angle 8. Now look at the figure given here. Can you name what kind of angles are these? If you guessed they are angles at a point, you are correct. These arms or lines are meeting at a point. So if there are several angles formed at a point and they are completing the circle, then they are called angles at a point, and the sum would be 360 degree. So here sum of all these angles will be 360 degree, and an equation will be formed, and you can solve that equation to get the value of unknown variable. Now look at the second figure also. Same way here, they are completing a circle. So all these angles, their sum would be 360. You'll write an equation to get the value of unknown variable. So they are called angles at a point. Now look at these examples. Here in both the cases, the angles are formed on a straight line and their sum is 180 degree. Since they are completing a straight angle, so their sum is 180 degree. Can we call them supplementary angles? Yesterday also we discussed. The answer is no. We cannot call them supplementary because in supplementary there are only two angles. But here there are more than two angles. So more than two angles are there. whose sum is 180. They are called angles on a straight line. So I hope now the definitions are clear. You must revise the definitions. I repeat, go through the definitions, each and every definition, before you start doing the exercise. Do not hurry in start doing the exercise and your concepts are not clear. So go through the definitions. If you have any doubt, ask, but definition should be clear to you. So now open exercise 10.1 of your book and look at question number 5, first part, because question number 1 to 4 are very easy. You just have to find. Question number 1 is can be done orally in the book itself. We'll do it in the book. And question number 2, 3, 4, you have to find just the complement or the supplement. For complement, you'll subtract from 90 to find the complement, and for supplement, you'll subtract from 180 to find the supplement. So try the questions which will be given as home assignment today. Look at question number 5, first part. Find the angle which is equal to its complement. Angle which is equal to its complement. So let the angle be x. Now since it is equal to its complement, so complement will also be x degree. And since they are complementary angles, their sum would be how much? It would be 90 degree. So x plus its complement x equal to 90 degree. So 2x equal to 90 degree, and hence x equal to 90 divided by 2, that is 45 degree. So each of the two angles, that the angle and its complement, both are 45 degree each. Read question number 7 carefully. Two supplementary angles are in the ratio 2:7. Find the angles. So there are two supplementary angles and their sum is, their ratio is given 2:7. So let the two angles be 2x and 7x. We attach a variable to both the numbers of the ratio. Now their sum is 180 degrees. So 2x plus 7x equal to 180 degree. So 9x equal to 180. So you'll get the value of x as 180 divided by 9, that is 20 degree. Now this value of x, if you put in the angles, that is 2x and 7x. So 2x means 2 into 20, that is 40 degree, and 7x means 7 into 20, that is 140 degree, and hence we get the two angles as 40 degree and 140 degree. That is the answer. Question number 9. Read the question carefully and then look at the solution. If an angle is half of its complement. Now try to understand the language of the question. An angle is half of its complement. So if you let one out of those angles be x, I am not saying that angle is which is half. So let one of the two angles be x degree. So the other angle, since one angle is half, so the other angle would be x upon 2. So one angle is x, the other angle which is half will be x upon 2. And since they are complementary angles, so what will be their sum? Their sum will be 90 degree. So x plus x by 2 equal to 90 degree. Now here x by 2 a fraction. So we'll take LCM. 2 is the LCM. So we'll take LCM and simplify. So you get 2x plus x upon 2 equal to 90 degree. So 3x upon 2 equal to 90. Now here you can cross multiply. So you'll get the value of 2x as 180 degree and x you will get as 180 divided by 2, 180 degree divided by 3, that is 60 degree, right? So the two angles were x and x by 2. Now here you got the value of x as 60 degree. So the first angle is x, which is 60 degree, and the second angle is x upon 2, that is 60 divided by 2, which is equal to 30 degree, and hence the two angles are 60 degree and 30 degree respectively. Now today you have revised the definitions. The book pages were shared with you where you have all the definitions given in the book. You can go through the videos again. You can go through the pages of the book again, but make your concepts clear, because after this you'll be studying lines and parallel lines where you'll be needing these angles. So if the concepts are not clear, then you'll not be able to understand parallel lines as well. So do revise the definitions today, and then only start doing the exercise. And these questions you have to do in classwork and homework. I'll be posting in separate instructions. Thank you.